All right, we will go ahead and get started in this on our final day of virtual CEDIA. And thank you, everyone, for joining us at AV over IP, streaming onto your network one source at a time. Now, as with any of the presentations I've been doing, we're going to mute everybody until the end of the webinar, just so we can get through everything. There's a lot of content, and I think if we go through it, smoothly, it'll make it a lot easier for everybody. However, I do encourage any questions you have, throw them up at any point in time, use the chat box. Let's get them all up there. If I don't have a chance to answer all the questions at the end, we will get back to you with answers, but overall, I want to make sure that anything you've got, if I've got the answer, I can do it now. If not, we'll get back to you. The webinar is being recorded so that later on you can absolutely view it again if needed. And as usual, people who know me know I'm always available to answer any questions. I believe heavily in the more education we give everyone, the better it is for everyone. For those of you who do not know me, my name is Nathan Holmes. I'm the Director of Training and Development with Access Networks. I have been in the custom AV industry since the mid-90s. This was going to be my 23rd or 24th CEDIA. I continually strive to get myself educated in new ways. There's a number of certifications I have up there on the screen. Pardon me. And I'm also on CEDIA's Technology Council, where we help steer CEDIA in the right direction for education on where we believe new and emerging trends are going to affect the industry. And we want to make sure we've got as much education ready to go for those as they become relevant. Additionally, if you don't know Access Networks, we provide industry-leading enterprise-grade networking solutions for the modern home. We provide both distribution product that you configure yourselves, and we've got full custom network design and support. I was Access Network's second dealer, so I've actually been working with the company for over 12 years. And I can tell you from experience, this IT team that provides support, not only do they understand IT, they understand the products we deal with in the AV industry day in and day out, which really helps from a troubleshooting perspective. And I think AV over IP is a really good example of where this bridges the gap significantly, and having somebody who understands both the network and the product that use it is really beneficial. Now, AV over IP is not, well, it's new, but it's not new for us. We, for years, have been distributing sources throughout the house and using a variety of different methodologies to do so. I mean, I came back from the world of component video distribution years and years ago. This just gives us a new platform. We're using network switches to be able to distribute sources throughout the house, and it becomes really cost effective. And we're going to talk a lot about how this happens, how to design it correctly. But overall, I just want you to see that it can work really easily, be really stable, and there's a variety of different solutions you can choose to fit any budget and really the needs of whatever your client wants, from nearly uncompressed to significantly pressed, but still able to distribute scenarios. And they all leverage the same things. So we're not really going to talk product. We're going to talk how the technology works so you can understand how to give your customer the experience they're looking for. And we'll start off with, why do we want to use AV over IP? What benefits do we gain out of it? Once we finish that, before we can really get into too heavy in the networking, I want to talk about some of the things that are happening that most networking guys in our industry aren't aware of, because there's some different ways that network traffic is utilized with AV over IP compared to what we're accustomed to doing. So we need to talk about some of those basic concepts before we dive into what is a best practice network design. There's lots of ways to approach networking. Some are going to give you better results than others. So we've really worked together to work with manufacturers to develop a best practice approach to really aid in your success. Then I'll finish up with some basic concepts that will help you understand how to troubleshoot AV over IP installations, not only effectively, but efficiently, quickly, and approach it systematically in a way that should reduce your troubleshooting time and really be able to determine if the issue is network related or something else. Let's begin. Why do we want to use AV over IP? Well, years ago, digital video was simple. Took a couple sources, you had a single display, and boom, we connected the sources straight to the display. We use an HDMI cable. We all knew this. We started off before with component video, but HDMI was awesome because it was a single cable. And it carried all the audio, all the video, and Ethernet control, everything over this HDMI. It made secure content protection, so manufacturers really wanted to embrace it to protect all of their content. But it was really designed for direct connection from a source to a display. Well, that was cool, except for we wanted just a basic display on a wall and all my sources hidden or things distributed throughout the house. So we had to come up with a solution that would allow us to take multiple video sources and send them to one or multiple displays. So enter HDMI distribution systems. They were phenomenal at doing that. They retained all the original video, Ethernet, and control content, and it maintained content protection, which was great for the manufacturers. Made it, there were some hurdles we faced in the industry, but overall, it didn't take long to work really well. And some of them even allowed us to process the signal from one source across multiple displays or multiple sources to a single display. Either way, it came up with some really neat ways for us to address some unique design requests, leveraging HDMI signal and what we could do with the distribution system. But the problem was, when it came time to upgrade, you generally had to upgrade the entire system. That's because you'd have a main chassis, and the sources were connected directly to that chassis via HDMI, or sometimes you'd have receivers that would come in with different transmission mediums, from coax to Ethernet to different things. Not only Ethernet, but they did Cat cabling. Either way, it was expensive when you wanted to upgrade, and you usually couldn't upgrade just a portion. You had to upgrade the entire system. That could be really, really costly. By utilizing networks, network switches, and you leveraging, what the technology they've used for AV over IP, it allows it to be a much more scalable system, and you only have to upgrade the individual components you need to when you go through and do upgrades. You don't necessarily have to do the whole thing all at once, which is really beneficial for your customers and not having to do overpriced things. But this came with its own hurdles and things that we had to figure out, because right now, not really any way to connect a digital video source that comes out HDMI. You can't really connect that to the switch, and you can't really connect this Ethernet switch directly to the TV to distribute video either, at least not yet. So what we need to do is, since we can't take an HDMI cable and connect it directly, we need to actually use encoders and decoders. An encoder will take a HDMI signal, encode it onto Ethernet, and then send it to the Ethernet switch. After that, the switch will forward that information out individual ports to decoders that are located at the displays, and that'll convert it back from Ethernet into HDMI signal. Pretty straightforward. But let's think about what's happening here. We're taking multiple different subnets, subcategories of information. So we got audio, video, Ethernet, control, all of them sharing that same single connection. What's really cool is we might not have to have all of that go to one location though. You might have a projector that's only going to receive the video, nothing else. And then a surround sound receiver that's going to receive just the audio. Oh, but in another room, you could have a TV receiving all of it and control different things you want. Either way, you can choose which portion of those different streams you utilize if you have the right product, but they could be routed independently and you could subscribe to only what you needed. This was really awesome. But it also raised some questions on, okay, well, how much bandwidth do I need then? Overall, the thing to consider is manufacturers have pretty specifically designed it to be based on one of two standards, either 1 gigabit or 10 gigabit solutions, meaning each switch port that's dedicated to a particular endpoint needs to be either a 1 gigabit or 10 gigabit port dedicated to that device. And when you're talking about multiple ports and multiple amounts, you always do multiples of that one thing. So 2 sources takes 2 gigabits, 3, 4, all those things. So basically the combination of all those different subcategories of information are viewed comprehensive when looking at the overall bandwidth. Okay. That's a real basic understanding of AV over IP, but before we can get into how to design it correctly, let's look at what's happening on the network. The first thing I want to talk about is network traffic types, because there are different types of network traffic and each one operates and performs and works differently. We're going to need to learn about something called a multicast group. Some weird little initial called IGMP. No, it's not some little imp running around. This is actually Internet Group Management Protocol, so IGMP. And all those things combined are going to help us understand how AV over IP works. Starting with network traffic types, the first traffic type we're most accustomed to in networking is unicast. This is where you take traffic from one IP address or destination address and specifically to another destination IP address, one-to-one. So, you're either communicating with your control processor from a touch panel, or you're going straight to this device to communicate with it. It's a one-to-one communication path. I'm taking this NVR and opening a single connection to this camera. The communication can be TCP or UDP, meaning, transmission control protocol, where they evaluates whether or not the packet was received, or UDP, where it's just one direction and you hope it gets to its destination. This has always been the predominant form of transmissions on LANs on what we have dealt with in our industry for years. That's just really all we played with. They were all pretty easy to do and not a big deal. One of the other transmission types that we don't generally see, or a lot of times know are happening, are called broadcast transmissions. This is where a datagram is sent from one sender to all the possible endpoints within a broadcast domain. So this means that if we've designed a Class C network with 254 addresses, a broadcast is going to go out to every single address in there. It's kind of like your mailman going through. He's going to drive to every single mailbox, deliver. He's, here, this is a, what do they call it? Junk mail that you're getting. He gives it to every single mailbox, and then you either throw it out or you read it. Well, that's kind of what's happening with the broadcast transmission. Every single device in that subnet will receive a broadcast transmission. It's also one of the reasons why we make sure that we design our networks to be smaller groups of things, and you don't automatically start giving yourself big Class B networks, because broadcast transmissions take a really long time then. And they can cause dramatic strain on a network. Some examples of broadcast transmissions are Bonjour. This is an Apple type of device discovery. There's address resolution protocol. And there's a lot of things like in our industry, we see Crestron Home, we see Savant, we see the new Elan. These control systems, when you're opening your app and it's automatically discovering what devices are out there that it can communicate with, these are broadcast commands that are sent out to every device within that same subnet. So we see them, we don't necessarily know what's happening, but those are broadcast commands. Multicast commands are in between those two. This is where you can send a transmission from one device to many recipients. It can go to one, it could go to all, but it doesn't have to. It can go to any combination there within that. And what happens is a switch will receive that multicast transmission and then forward it to any port on that switch that has subscribed to receive it. It works pretty cool. This can significantly reduce network overhead because you're just taking one copy and forwarding it everywhere instead of having individual conversations. And this is the key technology that's leveraged in AV over IP. And I'll show you why it's so important. And I like to use IP cameras because I think they're easier for us to understand as our starting point in explaining it. So let's say we take a little 5 megapixel IP camera, no big deal. And we have an Ethernet switch and we have an NVR. Okay, we know to get to the NVR, we connect the camera to the switch and then from the switch to the NVR. Straightforward. Each conversation to that camera, though, is going to require a dedicated amount of bandwidth. So let's say my technician configured it correctly. He configured it for H.264, high res, 30 frames a second. All right, that's going to give me a 24 megabit stream coming out of that camera. And my switch will then send that 24 megabit stream to that NVR. So right now, we're just doing unicast communication. Well, what happens if I also want to view that same camera on a touch panel? That touch panel will initiate a request for a conversation with that IP camera. And now that camera is going to send out a second 24 megabit stream that is going to the switch and then going to the touch panel. Let's say you watch it also from your laptop. Boom. Here's a third 24 megabit stream because each of these are unicast conversations, dedicated one-to-one conversations. Now, that's not really a lot of strain. That's only 72 megs. That's not even going to strain a 100 meg network. That's pretty straightforward. But what would happen if my technician made a mistake? And instead of setting my camera up for H.264, he set it up for MJPEG. Now I'm looking at a 337 megabit stream. Boom, those three devices connect to that camera. I'm now requesting over 1 gig of traffic from that camera. It oversaturates that link. The link stops functioning. Nobody gets to see the video, all because of two things. One, the fact that my technician configured it wrong, but secondly, because of the fact these are all unicast transmissions. So every device that communicates to that camera, it's a new conversation, new conversation, new conversation. Well, that wouldn't work so good for AV over IP because remember, we talked about how you define that network, each individual source needs to have unblocked bandwidth capable of either 1 gig or 10 gig based on which solution you're using. And that's because you can easily have, I'm going to use 1 gig solutions throughout a lot of this because I think it's just an easier number to work with. But let's say you have up to a 950 megabit stream. All right. Well, that means if you were doing one device and you're doing a unicast type of transmission, that would be fine. But if you opened a second display trying to watch the same video source, now you'd have 2 unicast conversations back to that encoder. 2 gigs of traffic can't travel down a 1 gig link. Boom. You've oversaturated the link. Can't work. System's done. Enter multicast. Multicast can solve this scenario because what's happening is it's the switch that's making copies for anybody that wants to view it. Therefore, coming out of the switch or coming out of the encoder, it's just a 1 gig link, and going to each of the devices is a 1 gig link because it's just a single 950 meg transmission that your switch is making a copy of and forwarding. You notice I'm going to say this a lot through this conversation because I have a lot of guys that I talk to that are like, well, can't I get just away with using this switch or this switch? You're going to see your switch is critical for all of these things that are happening. So it's really important you use a really high quality switch for your video, especially because it's doing a ton of work. Important to keep that in mind. So for multicast to work, remember, it doesn't just go to every device. That would be easy. Just send it to everyone. Or one device. Okay, just give me that one address. No, it goes to a group of people or group of devices that could shift and change at any given time. So to understand how that works and to give a parameter to that, we create what are called multicast groups. A multicast group refers to a specific set of network devices that are either transmitting a multicast transmission or the receivers that have requested to receive a specific multicast transmission. So if I take this Apple TV going to this particular encoder at 10.11.10.51, and it's going to send out a message, a stream to be received by these decoders, they all have to join a multicast group so that the switch knows, oh yeah, this one's sending me information. I'm going to forward this information onto each of these devices. But it's even a little different than that because if you notice, the name of the multicast group looks to be an IP address. Well, it is, but it's a very specific IP address. There are a dedicated range of IP addresses which are reserved for multicast. They range from 224.0.0.0 to 239.255, 255, 255, 255. However, there's only a limited amount that you can use for private addressing. Now, the ones that are available for private addressing that are generally accepted, meaning the most commonly used and the preferable group range, are 239.0.0.0 through 239.255.255.255. One of the big things to consider is, like I said, anything in that range, or a lot of things can be used, but you've got to make sure when you are defining the multicast group names, so the multicast IP addresses you're using, that you use addresses that are not in what are known as a link local multicast addresses, 224.0.0.0. That particular subnet contains all the multicast link local addresses like broadcast commands and discovery, things like that. And if you assign one of those addresses as your multicast group IP address, you will create havoc in the multicast world on your network. So I recommend sticking in the 239 address range. It's going to be a lot easier and a lot safer. Now, each manufacturer, though, may suggest a more specific set of addresses. And I always recommend following some manufacturer advice on this because when you call in for support from them, you want to be able to not have them focus on something other than how to support what's happening, not focusing on something like, oh, you chose a different IP range. That's bad. Okay, stop worrying about that. Choose what they recommend and then move on. For me, I like to use a standardized practice, though, when I am assigning those multicast IP addresses so you can understand what's going on and where the streams are coming from. And I'll show you what I mean. So let's take that example, right? An Apple TV connected to a video encoder. The address of that video encoder in my network was 10.11.10.51. Okay, that's its Ethernet IP address. The multicast address for the stream, though, that it's going to transmit, I'm going to define that as 239.0.51.2. Basically, I've taken the 4th octet of the IP address of the encoder and used it as the 3rd octet in my multicast address. Therefore, whenever I'm doing troubleshooting, it's real easy for me to go, oh, that's the 239.0.51 stream, so I know it's coming from the encoder whose IP address ends in 51. It really helps in your troubleshooting, and it helps you make sure that you're not replicating, using the same multicast address for multiple devices. It also makes sure that you've got space between your multicast addresses, because different manufacturers will use a different number of substreams based on different aspects of the actual AV over IP scenario. So this is one example. Overall, I think it's just important for you to come up with a standard practice on how you approach it, and understand that the multicast address is something defined by you to represent the group, multicast group, where that stream is going to be sent to on the switch, and other devices are going to subscribe or request to receive that particular stream. Because what happens is, when a transmission arrives at a switch port, a switch always evaluates what is the destination for this packet, this data frame. Is it going to a MAC address in this subgroup? Is it going to something I need to forward to the gateway? I'm a switch, what do I need to do with it? When it receives a transmission for a particular multicast group, if it hasn't already created the multicast group, it has to create it. And then any devices that have requested to join that multicast group, it adds the particular port that it receives that request on into its multicast group. Overall, everything's happening at layer 2 on MAC addresses, because it always does on switches, but the switch itself is doing a heck of a lot when it comes to multicast. Now, it does this through leveraging of a whole bunch of tools that are covered under something called IGMP, Internet Group Management Protocol. It's the set of all control messages that multicast or IP multicast enabled devices send to each other and know how to communicate with each other. This is a message that it can use to join a group, leave a group, create a group, broadcast a group, all these different things. There a whole group of protocols and messages that are sent, and there's 3 different versions. The first version was V1, then V2, and now we also have V3. Each of them have some very different commands in there. So it's critical that whatever version of IGMP is being used on your endpoints, your encoders and decoders, your switch is configured to have the same version of IGMP running on it. It's kind of like, I can speak English, somebody from London is going to speak the Queen's English, we're going to have close conversation, but some words in there that they're going to say mean something totally different for me, and so on and so forth. We don't want that to happen when we're doing video over IP. So make sure, it's critical, check your IGMP version. Whatever the manufacturer is using on the endpoints, set the switch to it. Generally, this is going to be V2. V2 works in all applications except multiple endpoints. I'll talk that a little bit, that are on remote switches. I'll talk about that a little later, but generally V2 is what you're going to end up using. All right. So once a group is established and we've got the proper IGMP version in use, what happens is, when a multicast enabled switch receives this transmission from the encoder, it creates a group. And then once the group is created, other devices can send join messages to join that group. This happens through something called IGMP Snooping. Snooping is a feature of a switch which is designed to reduce something called multicast flooding. Multicast flooding would be, well, I don't know where any device maybe wants to join this, so I want to just flood to everything. No, what you want to do is you want to turn off multicast flooding if you have the option to do so, and use something called snooping. Snooping allows a switch to listen to multicast control messages, the IGMP message. So when a decoder requests to join a particular multicast group, it's really sending that all the way to the encoder, but the switch is listening to it. It's like, hey man, I just heard somebody say they want to join this group. It came on port 7. I'm going to add port 7 to this IGMP group. By listening to these conversations, the switch maintains a map of which ports will receive certain multicast streams. And they do the same thing with leave messages. So by snooping the join or leave messages, the switch can add or prune ports from its overall list of who's supposed to get a multicast transmission. So we'll go back to our diagram that we're saying here. And so far, the only thing that's happened we can see in our multicast snooping table, there are no members. So we've had our encoder has sent a transmission to the switch. The switch has created this multicast group called 239.0.51.2. And the Apple TV is constantly sending information. It's just streaming it to the switch. And that's arriving on port 1, but it's not going anywhere because nobody's requested to receive this transmission yet. So it's doing nothing. As soon as one device says, hey man, can I join this multicast group? I want to be a part of the party. The switch will now evaluate what port sent that, and that request came in on port 11. So it's now going to add port 11 to that multicast group. And as soon as that happens, the switch starts forwarding a copy of what was coming in from that encoder on port 1, forwards a copy straight over to port 11. Now, when another one asks to join, hey man, what about me? I want to join the party too. Now, port 15 has also been added to the conversation. So now the switch is making 2 copies. Pretty straightforward, send it in. Anybody who asks to join, I'm going to make you a copy and send it to you. It sends it to the port. The switch could care less what's happening, how many decoders, anything like that. Remember, it's on a port by port basis. So when it receives a join request from a port, it's adding that port to the Igmp snooping table. Now, when this transmission gets there, and we've just kind of gone, it's going to make the 2 copies, each one of them is still only going to receive a 950 meg stream maximum, which is awesome. That's what we were trying to get about, with using multicast. But what happens to keep the switch always sending information to those ports? I mean, how do we know that it still wants to receive it? How do we know it just didn't, fade away? Well, on your switch that's running all your endpoints, you want to enable a feature called an Igmp Querier. An Igmp Querier will send out periodical reports, basically requests to say, hey man, what multicast groups do you want to be a part of? And the device will then respond with, these are the groups I want to join. Even if it was already joined, it's called a join request. It says, man, I want to be a part of these groups. I want to be a part of these groups. So every so often, this Igmp Querier is going to keep going out and say, hey man, do you want to be part of the group? And it'll update all the members of the group. Each VLAN can only have 1 active querier and 1 active switch that's acting as the querier. You need to remember that. This is very important. If you happen to be using multiple VLANs, well, keep in mind, a lot of routing appliances use PIM, which means they've enabled the querier on the routing appliance itself. Whichever VLAN is containing all of your endpoints, the querier needs to be disabled on the routing appliance and make sure that you've enabled the Igmp Querier function on the switch that all the endpoints are connected to. This will enable all of that traffic to stay on that switch. People who've forgotten to do this and they've got the querier enabled on the router will then, hey man, send me all your traffic and I'll figure out where to send it. So now all those video endpoints are going to send all their traffic across the trunk to the router, crushes the links, makes the whole network stop working correctly. Bad news, don't do it. Set the Igmp Querier on the 1 switch that contains all your endpoints. This diagram will kind of show you what I'm talking about. If all your endpoints are connected to that switch at the bottom, the layer 3 primary voice over IP switch or video over IP, and it's got the Igmp Querier active on that switch, because there are no devices on that core switch that are requesting to join the multicast groups that those encoders are creating, no multicast traffic is going to traverse that link because nothing on that port has come into that second switch and said, hey man, let me join the party. Nope, there's no devices requesting it. So that's the biggest reason to keep your querier on that remote switch is none of that multicast traffic will traverse back to your core and other switches if it's configured correctly and that querier is active on that switch. Very important. So that's how we get to join the group. How do we leave the group? Meaning, you know what, I'm done watching Apple TV and I want to go watch, DirecTV now. Well, if I didn't leave one group and I joined another group, now I've got 2 different transmissions arriving at my switch port at the same time. What do we know? 2 950 meg transmissions can't travel down the same 1 gig pipe. It isn't going to happen. So you have to leave one group first and then join another group, and you got to do it fast enough so that your customer doesn't see something happening. It's got to be instantaneous to them. That can get tricky. So the first thing is to understand how a leave request happens. So version 1 Igmp didn't have a leave request. So the only way to leave a group is you would stop responding to the Igmp query. So when that query came out and said, hey, tell me what groups you want to be a member of. If you stopped responding after it got done querying all devices and updating the list because you hadn't responded, now it would just eventually stop sending that to you because you no longer were a part of that group. It pruned you out because you lacked the reply. Well, version 2 added a request where you could specifically request to leave. So it's like, you know what? I want to leave this group. Okay. So it doesn't happen immediately by default though. So by default, even though it's requested to leave, that port is still going to be active in the snooping table. Because what happens is when the querier receives a leave request on normal v2, it sends it's not a broadcast, it's a multicast query, but it still sends a query out to all members of the current group you're asking to leave and asks every member of that group to reaffirm that you still want to be a part of it. So basically, if you were watching Apple TV, it would send out, hey, and a request to every other port that's connected to watching Apple TV saying, are you still want to be a part of this conversation? If so, reply. If not, I'll remove you. That means it can take as long as a full query response, which could be many seconds, sometimes 30 seconds or longer before it would actually prune that membership. So enter something called fast leave. This means as soon as the switch is snooping to that leave request, it goes, oh man, port 15 wants to leave. Boom, it will immediately remove you from that group. Well, that's awesome. That's exactly what we're looking for, immediate, and then we can join a new group. So it's really important that you turn on fast leave or immediate leave, depending on what your manufacturer is asking for, so that immediately upon requesting to change sources, it will leave the group you were connected to and then issue a command to join the new group. This will allow you to switch sources without delays, which is important. So let's tie in everything we just talked about. What is the best practice for AV over IP? Really, really simple. Connect all your video endpoints to a dedicated Igmp snooping capable switch with the Igmp Querier enabled. Boom. Doesn't matter if it's a small, medium, or large deployment, it's all the same thing. Make sure you're always using the same Igmp version 2 or 3, whatever is being used on the endpoints, you match it on the switch and put all your endpoints on that one switch. Doing so means that as your network grows, it doesn't, even as your AV over IP side grows, it doesn't change how the rest of the network is performing. You're still going to connect, recommended best practice is always a 2 gig lag, so link aggregation group with 2 Ethernet cables, or 10 gig if you want. But either way, link aggregation gives you redundancy. And you connect all your switches that way, even your daisy chained ones if you had them. And you can see in this diagram, no video traffic is reaching a remote switch. You never really want a daisy chain, but overall, the key to takeaway is there's no video traffic leaving the Igmp enabled switch. So it's acting as a matrix switcher, which gives you your easiest troubleshooting, gives you the best system design. And you'll notice I've said dedicated switch. Don't put any of your other Ethernet devices on this switch. Leave it as video. It simplifies your troubleshooting. It is what it is. Your client is paying for a video over IP system. Give it to them. Don't share your switches unless you absolutely have to, because it's going to change your troubleshooting time, different things. Make a dedicated switch. It's just a better approach. Now, I'm going to touch on it because it's important to understand the concepts, because sometimes we do end up having to add remote endpoints. Now, if you need to add a remote endpoint and it's a single endpoint, that's not the end of the world. The big thing to consider is you have to have unblocked bandwidth equivalent to the number of remote endpoints plus a minimum of 1 gig for standard Ethernet traffic. So what I'm saying is if you could have 2 Ethernet cables there between the switches, okay, cool. We got a multi-gigabit link aggregation group. We could have 1 remote source. We're good. Multi-gigabit fiber is usually more recommended because you got more flexibility. But in this situation, you're fine. And because you only have 1 remote source, you could still get away with using Igmp v2. If you have more than 1 remote endpoint, Igmp v3 has to be used. Because think about it. If more than 1 source is remote, you could have more than 1 source connected to the uplink that's leaving your video over IP switch. And remember how v2 works. If the port sends a leave request, the switch prunes that port. So therefore, if you had 2 remote endpoints watching the same source and one of them requested to leave, it would kill the source feed going to both switches. And it would take a while before it came back and reestablished that connection. So v3 could fix that. It's a whole nother ball game, not for this not for this conversation when you're doing remote endpoints, but Overall, there's a lot. I just wanted you to realize there's a lot of things to take into consideration, and that you don't have to if you just keep all your endpoints on the same switch. All right, let's do some quick diving into troubleshooting now. I like to take a layered approach to troubleshooting, which means I'm going to start with the physical layer of the OSI model, layer 1, then go to layer 2 if that didn't work, the data link layer, and go to layer 3, because those are the 3 layers really under my control. Everything else in the higher layers, it's more difficult to troubleshoot, and a lot of times it's not a network problem at that point. And I'll show you what I mean. The OSI model was created very specifically to categorize different network activities in a layered fashion. When troubleshooting, it's always best to use the OSI model and take one of these approaches. You start from the bottom up, meaning from layer 1, going all the way up to layer 7 through the data link, the network, and then the upper layers. Or you start from the top down, the application layer, the presentation, session, transport, and then you get to the 3 layers you really work on, okay, the network layers. Cool. You can divide and conquer, but this way it takes a little longer, and this is what guys tend to do. They're like, oh man, I think it's a network issue. No, it wasn't a network issue. Oh, well, now do you go up or down in the OSI model? Well, you can go up. It's not a transfer layer issue. Oh, let's go down, data link. So you can see this isn't as efficient because you're going up and down, and it's not as systematic. If you start from the physical layer, it gives you the ability to go, look, is the network cable plugged in? That's usually a good first step. Is there a link light on the Ethernet port? Okay, yeah. Is it a link light on the Ethernet device? Yep, okay. Is the link light flashing to indicate that there is traffic going across that link? Yeah, okay, cool, that's another tip. What about Ethernet power? Is it delivering the right Ethernet power? Keep in mind, you've got some endpoints that are PoE, others that are PoE plus, others that are UPoE. So if you're not delivering the right PoE power, you're absolutely gonna have issues. And sometimes that can change. Like you might be sending a 1080p source the device only pulls PoE, and then you go to a 4K HDR, and now it's pulling PoE or UPoE. And if you're not getting enough power, you're going to have weird anomalies and fluctuations. So always make sure your PoE power being used is correct, and that's something to check if you're having weird anomalies. If you check layer 1 and is good, go to layer 2. Is the switch port up? Meaning, does the switch port show connectivity in the management console of that switch? Is that switch port programmed to be on the right VLAN? Okay, that's a good way to determine, hey, that's why I'm not communicating with it. It's the wrong VLAN. Is the MAC address of that endpoint, that device listed in the MAC table? That's if you don't have layer 2 connectivity, you're not going to go to layer 3. Check the interface statistics. See what packets have been sent and received. Are they being sent at the right rate? And is it what expected? Am I only sending 100 meg and I expect 900 meg? What's going on here? Look at the statistics. If you've done layer 2 and you're good, check 3. Does the device have an IP address, or is it showing a talkback address? Oh, okay, I didn't get a DHCP, or it wasn't statically assigned correctly. Can you ping that IP address from the same subnet, or is there an issue? Can you ping the device from its default gateway? Check to see if there are any drop packets. Remember, frames are layer 2, packets are layer 3. See if there's any drop packets on there. Additionally, check the multicast table on the switch to see if the transmitter and receivers are, showing that they're correctly located, meaning what ports they're on, they're showing in the right groups, all those different things. And check the multicast IP settings to verify that they match the planned address scheme. And make sure that you're not using any of the link local multicast addresses, because like I said, that can cause some significantly odd issues and instabilities. And check to make sure that you don't have more than one Igmp Querier running. It's got to be one Querier, one subnet on that primary switch. Generally speaking, if after you've checked all that, everything's working great, it's likely that the problem's on a higher layer. Now, those higher layers could be completely outside of the network, meaning it could be a resolution setting, a bitrate setting, EDID, any of the things that are video related that don't even have anything to do with networking, but they could absolutely be causing an issue where you would see and question whether from a network perspective it's working. By using a layered approach, you can really get to the bottom quickly and effectively determine what is the problem, not just guess at it. Overall, hopefully I've shown you AV over IP can provide a robust, scalable, and really cost-effective solution for distributing AV. There are some network essentials you got to reuse that are different than before. We're having to learn about unicast, broadcast, and multicast, because now we got devices that are using all 3 instead of just unicast. So we're having to grow our knowledge here in networking to be a little more understanding of what is going wrong when it's not working as expected. Overall, follow the best practice network design. It's going to diminish your troubleshooting. It's going to maximize your profit and maximize your client experience. If you deviate, you're just throwing caution to the wind. It's never worth it. Use the Osi model when you're troubleshooting. It will help you troubleshoot more quickly, more effectively, and more efficiently. Throwing our shameless plug in, boom. Our core systems are designed from the ground up to support AV over IP success. Our network designs are comprehensive AV over IP, and I do multiple different tests and configurations where we will vet designs for different manufacturers. I've built a whole video over IP lab where we will test everything and get to the bottom, and then custom tailor our configurations to support the various manufacturers in the industry. It helps make sure that we do the right solution. We've got solutions that can go all the way up to 6.4 terabytes stacked. Think about that, 6.4 terabytes. I've got multiple 100 gigabit solutions out there. We've got 100 big backbones going around a property. Why? Because you need it for the number of sources that they're trying to send around, amount of bandwidth. Overall, enterprise-grade hardware is always best. You can see just a little bit here how much more we're depending on a switch to work correctly. Use the right switch. You're going to have a much, much, much better design and experience. Our in-house design team will look at your systems and design the appropriate network to support your devices that are being used, both from AV over IP and understand how they interact with the rest of the devices. You know, you've got a lot of stuff on your network that uses multicast, multicast discovery, and you've got to know how it's all interacting with each other to make sure that the experience and the network performance is as expected. Additionally, if you are programming by yourself, I said in the beginning, you can see there's a ton of activity happening directly on the network switch level. Just putting in one of our switches for video over IP hanging off even a more basic network will still give you a better experience. They're super easy to configure. I absolutely recommend reaching out to your territory sales manager and getting to know these switches, because they are around the same price you're paying for the prosumer stuff we have, and they're true enterprise grade and very expandable. Overall, thank you for joining us. My name is Nathan Holmes. Contact us at clientservices@accessnetworks.com at any point in time, or my first name last name at accessnetworks.com. I hope you enjoyed it, and we're going to open up the floor to any questions.
Nathan, great job. That was so much fun. I have a great question from Todd Erdman, our reps up in the Chicago area. He has a question: how does the Querier function work with multiple switches? Is there any special configuration issues?
So you've got to have one switch in the entire VLAN that has the Querier running. It's kind of like, imagine a classroom of students. If you have one teacher in there asking questions, all the students focus on that one teacher, and the teacher can, listen to one question at a time and answer it. If you put two teachers in the room, there's kind of a lot of chaos. You know who's asking what question from who, from where. They interrupt each other. They talk over each other. It's vital to ensure that your Igmp Querier stays on one switch. It's also, I cannot stress this enough, 99% of the problems that I deal with people when it comes to video over IP is somebody going, well, hey man, I just threw it on a couple switches. It's no big deal. No, stop thinking that way. Use a dedicated switch for all your video over IP endpoints. Run all of your video over IP endpoints straight to that switch. Use one switch, be done with it.
Perfect. And then I have a question for Haley, believe it or not. We have some team members here, or actual clients, that are asking, how do they get the medium t-shirts?
Sure, we are happy to help with that. So there should be a link in our booth in our virtual swag section, so you can try there first. And if that doesn't work for you, you can always email us at cedia@accessnetworks.com, ask for a shirt, and we'll make sure that you get one.
And also, you got to tell us why you deserve our super sweet
Exactly. Yeah.
That is all I have, Nathan. That was very, very inclusive of everything that we want to know about AV over IP. I loved it.
Awesome. Well, thank you everybody for joining us. Normally we have a lot more questions, so hopefully I'm getting better at presenting this. Hopefully it was informative. And if you do think of something down the road, please don't hesitate to reach out. I try to be as available and responsive as I can be, and I think it's important that we divulge as much information to people as we can. So please feel free to reach out, and we'll get you taken care of.
Awesome.
Thanks, guys.